Now we will see what is meant by surge impedance and surge impedance loading. If you consider a lossless line, lossless means there is no losses. That means the resistance is equal to 0. You can take the conductance is also 0. Okay. So the characteristic impedance that is associated with this condition, that impedance, that characteristic impedance is called as the surge impedance. The characteristic impedance of a lossless line, that is R is equal to 0. So this value we represent as ZS. Okay, surge impedance is represented as ZS. So this is equal to ZC under lossless condition. So this you can write as, this was what we discussed, Z by Y, root over Z by Y. Now Z you can write as R plus J omega L, and Y you can write as, you can take the conductance as well, G plus J omega C. So here you can include the conductance as well. For a lossless line, R is equal to G is equal to 0. So if R and G are getting cancelled, you will be left out with J omega L by J omega C. So that is nothing but root over L by C. This is the surge impedance. Another name to surge impedance is the natural load impedance. Okay. Next we will see what is the surge impedance loading. This is the power that is delivered by the transmission line to a purely resistive load of resistance value equal to the surge impedance of the line. Surge impedance is root over L by C. Okay. And if the load that we have is a purely resistive load whose value is equal to root L by C, then that power, whatever power is delivered to that load, that is called as the surge impedance loading. Surge impedance loading, this is often abbreviated as SIL. So we can find this value 3 times the phase voltage square divided by the resistance value, which is equal to the surge impedance, right? Surge impedance we represent as ZS. This is the surge impedance. Okay, and here we took the phase voltage. So this is going to be how much? 3 V phase square root over C by L. Okay, and if you want to write in terms of the line voltage, then what will be V phase? V phase is equal to VL by root 3. Right, in that case 3 and 3 will get cancelled, so you can get VL square root over C by L. This is in terms of the line voltage. This is phase voltage, this is in terms of line voltage. One thing that you can see here is the surge impedance loading is independent of the length of line. Right, nowhere in the expression you have the length. Okay, so it is independent of the line length.